Hi everyone, welcome to this session with data mining with Altair RapidMiner. So, in the first place, why data science with Altair RapidMiner? As you all know, the data is increasing rapidly across the globe, right? So we have huge amounts of data, but the problem is how to make sense out of this data, right? So only a few resources who are very well equipped with coding, they probably till now are able to make sense out of data, right? Those people, those scarce resources are called data scientists. But with Alter Rapid Miner, even domain experts who might not be that good at coding, or they might not be highly proficient in coding, they can still build various models with Alter Rapid Miner. So what Alter Rapid Miner empowers is they empower citizen data scientists who can use code-free and code-friendly Alter Rapid Miner to perform data mining. So today, we'll in this session we'll look at is it salient features of Alter RapidMiner, why this has a unique proposition. Eventually, we'll explain a case study on vehicle insurance company, and eventually, I'll also share how you can actually uh, how you can build the case study in Alter RapidMiner. Let's dive into this. So first of all, what is Alter RapidMiner? Alter RapidMiner is an end-to-end code-free, code-friendly application. So basically, you have an automated tool with which you can do auto ML. So you basically need not have to write any code. So you can just use the auto ML, and then the entire the analysis it's built for you, and that you can do all the predictions just using auto ML. Also, you have the visual workflow. So somebody like a citizen data scientist can actually build the model using the drop and drag interface in Alter RapidMiner. Someone who is highly proficient in coding, they find, okay, maybe some things I want to still write my own code in certain features. That is very well accessible. So you can actually insert your Python code, so to speak, or any open source code in RapidMiner as well. So, what does Alter RapidMiner can do? It can actually do the entire data science lifecycle, starting from data engineering, all the ETL, extract, transform, loading, or it's like acquiring the data and data preparation till model building. So you can actually do all the data analysis, build a model, and eventually you can also deploy the model. So these are all the entire data science lifecycle can be done in Alter RapidMiner. So let's discuss a little bit about the features of Alter RapidMiner as well. So you see here the design window, the drag and drop window looks just like this. So where you can do the data importing first, and then you can you can just click drag and drop the widgets. You can also build the model, do the analysis, data preparation. Uh, you can apply the model. So the entire workflow is exhaustive. So you can actually build the entire model using the workflow. So let's discuss a bit about turbo prep. So data cleaning, as you might would have heard, so this data cleaning takes around 70% of the data scientist time. So, but what can a data scientist do to reduce this time? Sometimes, especially let's say you want to build a proof of concept, which you don't want to spend so much of time. Can you do it really fast? So turbo prep can definitely help in data cleaning, and it's more or less an automated tool where you can just click on the columns which you want to clean. Let's say substituting missing values, or you want to transform any column. All those things could be done, just by clicking on turbo, just making a few clicks in turbo prep. So let's talk about the auto model as well. So auto model, the most interesting part is you don't have to write any code, right? So it's just to build a quick prototype, right? It might not give you always as effective results as the drag and drop window, but it definitely gives you a quick prototype in which you can predict your target variable, and eventually you can also evaluate the data. So all the processes, all the different algorithms which you can think of could be done, be classification or regression, could be done using auto model. So next is how do you learn the tool, right? RapidMiner. Of course, you have lots and lots of YouTube tutorials, but then we also have a dedicated RapidMiner Academy where you have dedicated tracks for different professionals, be it data engineering professionals, be it machine learning professionals. So the track which you want to be master on, you can go to RapidMiner Academy and get yourself certified there. So, talking about how does it help the professors? Well, professors can actually teach the courses with RapidMiner being part of their curriculum. So it's kind of a complementary tool to the open source, right? So you can actually show your case studies, especially for the, let's say, for business students who are not familiar for coding. They can actually build make sense out of the data, right? And then build really models quickly in RapidMiner. So for students, as I already mentioned, the entire data science lifecycle could be built in RapidMiner. So you can do data preparation, you can do machine learning, you can do model deployment. All the three steps, the major steps, could be done in RapidMiner. So you can really quickly build prototypes, right? So even if you're a student from non-computer science or IT domain, you can still make use of Altair RapidMiner to really make sense of data. You can, and data, there's various kinds of data, be it text data, be it computer vision. So you can really build models based on your structured, unstructured data, different kinds of data. You can work with Altair RapidMiner. And for researchers, so the best part is they can analyze really large data sets, which can leverage 1,500 plus analytical operators. And the most important part is this free. RapidMiner is freely downloadable, so researchers doesn't have to can use RapidMiner at no cost, right? And also they can get the community support. We have a very active community here, so people help each other to solve the problems. So about so this is important a case study where Professor Dr. Andres Soffert actually have taught entire class using machine learning. So what he was looking for is actually he wanted to teach data science, but without requiring deep programming skills. So he used a code friendly approach in Altair RapidMiner, which enabled the faculty and students to not only access machine learning, but really they can solve the business problems without much of coding. So let's talk a bit about the case study. Now, the case study today we want to discuss is vehicle insurance fraud detection using Altair RapidMiner. So to detect vehicle insurance fraud, right? So that's a very common problem. Yeah. Most of the many times you see insurance companies face this problem where there is a fraudulent claims. So fraudsters arrange for accidents to occur or those things. So these things are very hard to detect by normal eye when you have so much of data uh, coming in. But how to detect? So, but what machine learning can do, they'll actually find a pattern out of this data. They can figure out, okay, these are the trends which fraudsters have. So most likely when a new use case comes to you, and then okay, this is most likely a fraudster as well. So how RapidMiner actually solve this problem, right? So what RapidMiner is do, they can actually detect risky customers before even going to model building. You can just use the visualizations to actually detect, let's say, in terms of attributes. Different attributes have like age, income, different attributes you have. Looking at those attributes, and let's say, for example, looking at the fraud rates, you can probably know which attributes are contributing more towards fraudulent customers. So this is really helpful before even building the model. You can do the analysis using RapidMiner, and just that too, just using the drag and drop workflow. So and down the most important part is when it comes to the predictions, right? You can predict using different classes. Like fraud detection is a classification you know algorithm. So basically you either a customer is a fraud or a customer is a not fraud. So when you want to know which customers are fraud, right? You need to predict. You need to have a prediction. Let's say, and you need to have classification algorithms to do the prediction. So in this use case, I have used two classification algorithms. You can of course use much more than that, but the idea is to find out which customers are fraudulent customers, and eventually we have also evaluated the model, how good our model is, right? So this use case actually gives the agents, especially insurance agents, a real flashpoint or a flag where they know that, okay, these customers could in the future turn out to be fraudsters. So before even going to the underwriters in insurance companies, they can pretty well know that this case might be a fraudulent case in the future, so they can really be aware of. So that's kind of giving you a fraud alert. So now let us look at the case study in RapidMiner. So here you can see the different attributes. Now one of the attributes is fraud found. Now these are target variable, which means that this is the variable which you want to predict, right? Whether the customer has been a fraud or not fraud. So now with this, you see the predictions as well. So this is the prediction which comes out of our machine learning algorithms, where it says, okay, the customer is actually fraud or not. So in cases, you see in the first case there, it's not a fraud, it's a false, but prediction is true. That means it's not rightly predicted. So most of the cases it is rightly predicted, but few cases it can be it didn't predict correct. So of course I'll discuss more on the performance of the algorithm. Based on this, you can decide whether you want to choose to use this algorithm, or you can tweak it further to make it better for yourself. So also we can compare different algorithms. So I'll come into the details, but first of all, let me explain the case study first in RapidMiner. So you can see here the workflow here, as I mentioned. So now this workflow is basically there are numerous operators, 1500 plus operators we have. So you can just drag and drop. For example, to get the retrieve operator, I can just type in retrieve here, and then I can drag and drop it here, and then I connect it to different other operators. So basically, so for here, for example, for retrieve operator here, you see here the repository entry. I can just get the data here. So here it is a fraud oracle data. So here you see this is also marked in blue. So this is the data we have chosen. So let's have a look in the data set. So the data set actually have different attributes like month, week of month, day of week, who is the maker, accident area, day of week. So different attributes. You can also look at the statistical view for the same. And if you really click for the open visualization, you can see for these attributes in detail as well. So let me go to the visualization window as well. So visualization window helps us to find out, as I was mentioning, the data analysis part, right? Before even actually you build the model, you can start analyzing the model and see, okay, which features could actually be resulting in fraudulent the frauds for us. So now if you see here, what I have here in the Y column, you have count fraud found, right? That means how many customers actually become fraudulent. In the x-axis, you have the policy accident count, days of policy accident. So basically, this means that after how many days of policy the customer has claimed, right? So does this attribute make sense? Let us try to figure out. Let's say, now what we can make sense out of this. So here is fraud found. P0 means it's a non-fraud, and 1 means it's a fraudulent case, right? So we are looking at the fraud rate here. So now if you see here, the fraud rate is highest in more than 30. So that means that most of the frauds have done by the customers who have claimed after 30 days. So mostly you see the customers are not claiming too early. They're claiming at least after 30 days. This is an observation you can look at. So let's say for the maker, right? That is now that doesn't gives a very good picture for us, because you can see Honda also has a lot of frauds. Toyota also has, Pontiac also. So you can clearly say which, maybe you can say these customers have these makers more frauds happen for this, but you cannot be very sure of this, right? Okay, so you can actually look at different, so number of cards. Let's look at number of cards now. From this is a little more clearer. You can see mostly customers who are having one vehicle, they have done frauds, but the rest, more than three or two vehicles, they have not done any fraud. So these are the observations which you make before even doing your prediction. So this gives the team, the product team, let's say, before going to the underwriter, a good idea that, okay, this case might be a little risky based on this kind of a data. And eventually they know okay, maybe they might not turn to be fraud, but it might take some time, because we had similar data like this before who has actually become fraud. So a new case comes and they put into this criteria, at least you know that, okay, these customers might be fraudulent customers in the future. So you can be a little bit wary of. Or okay, for example, let's look another case like first number of claims. Now this means where there are fraudulent customers who have not done any claims as well. Now this is where it becomes tricky, where you cannot clearly identify based on this, because there are customers who have done past 2 or 4 claims and then still making more claims, and they are frauds. So this is where certain variables might not be suitable, but certain variables are very suitable to find out which customers are fraud. So we can, in this exercise, I'll also help you to figure out which variables are more important to find out which customers could be fraudulent. So let's move back to the design window, and here the next step is to discretize data. So basically, this means that, okay, there are here, okay, here you can see certain results are discretized already, but you want to specifically discretize. So here we have discretized based on our age. So distribute the age in here in 4 bins. So that means basically it will be divided into 4 groups, the age. and you can further classify which group has maximum fraud. So you can just feed into the algorithm that specific age group only if you think that helps you to distinguish between fraudulent customers and non-fraudulent customers. And after this, the next step, what we have done here is we have converted the numerical variable, that is the fraud found, which I already mentioned is a target variable, from fraud found from numerical to binomial. Why I've done this? Because binomial, as you know, it's binary, right? So it's now whether it's a fraud or non-fraud. So it's a very simple thing. So you don't have multiple options here. So it's just two options. So I've converted into binomial. And eventually I have converted this to a target variable, as I was mentioning, this are level. So the computer doesn't itself know which is a target variable, but here we make it clear that this is a target variable. So, and then the most important thing I would say in this exercise is sampling, data sampling. Now this is a very important. So now in insurance companies, you see there will be very few fraudulent customers, but there are very high number of non-fraudulent customers, right? So that is something which you can actually go and see the statistics as well. So if you go and look at the fraud found, right, you see there are very few fraudulent customers, but there are lots of non-fraud customers. That's zero, right? That's marked by zero here. So now that is where we have to resample. And in this data set, we have kept 8% of the non-fraud data, but we have kept all the fraudulent customers. So that means that why this is important? This is important to balance the data. So when you feed the data, when you not feed the right data to the algorithm, that will be really not good for the algorithm to actually classify, because it will otherwise make a lot of false positives. So or let us say false negatives in this case. So most of the cases in this case will come out to be non-frauds, because mostly their cases non-fraud. So just to make the balance a bit, we've undersampled the non-fraud customers and kept the fraud customers as it is. So then this is sent to the multiply operator. So what multiply operator does here is it creates a copy. It creates multiple copies of the same sample class. So it'll create here now 3 copies for this. Now first copy goes to split data, second copy goes to determine influence factors, and the third copy goes to compare ROCs. Now let me try to explain you a bit more on what exactly is happening here. So why split data? Now the next part for us, now this is the data analysis part which I explained it to you. Now this part is modeling, the real machine learning model building. Now when you are modeling the data, you are sending 80% data to optimize parameters. Why it is important to divide the data into training and testing? Because you don't want to build a model on the test data, right? You need to teach the computer, like, okay, you have to learn first to find the pattern in the existing data. That's why training the model is very important. That's why we are here using optimized parameter to train the model here. Of course we are using cross validation. I'll explain it a bit. And now this train model, this results is coming to apply model, where the test data is also fed, so that model is built into this, and eventually we'll check the performance. So let me try to run this meanwhile. Okay, so while it is running, so it's taking some time, because there are 2 machine learning algorithms in this. So let me first explain you this. So there are 2 classification algorithms has been used here. One is a decision tree algorithm, and one is k nearest neighbor. So this is a classification problem, as I mentioned before, because you are classifying whether the customer is fraud or not, right? So there are regression problems also, but here this is a classification problem. So there are multiple classification algorithms like logistic regression, random forest, support vector classifier. But I have used only 2 because I just wanted to show how it's working here. So you can use much more number of algorithms just to make sure you get best results. So right now I've just used 2. So right now what we are using here is cross validation. So the data is distributed into 10 equal parts here. So of course this is training data, this is not testing data. So out of this 10 different parts, the 9 parts are kept for training, and the last part is kept for validation. Now this is for one particular set. Again, for the reiteration, so there will be 9 or 10 iterations, because in this 10 iterations, this 9 part will not remain the same. It will keep on varying, so that you always have 1 validation set and 9 training data, training set. So that helps to train the model and based on this average of this 10 observation will give you your validation accuracy. That is where you can say that that prevents overfitting, because that's coming from 10 different sets and the average is taken. So, and then next part is applying the model. Of course, we're applying to get the performance. This is again training data only, right? So this is the decision tree. Decision tree is one of the classification algorithm. The other one being used here is your k nearest neighbor. It also is again same cross validation, but in this case you have just 5 nearest neighbors, and eventually apply the model to check the performance as well for this. So this is, as I mentioned, this 80% of the data is here in this optimized parameters, and the rest 20% data comes to this apply model. So this model, train model, is coming here. So you are applying this train model on the new unseen data, the test data. So here this data is not being trained, 20% data. So now the performance which you'll be getting is out of untrained data, right? So because model is already learned in this 80% data, so it will be able to easily figure out, okay, how it is performing on unseen, because you expect always new customers coming to you, the insurance company, and these new customers, and then they'll apply the model on this new customer, and then they figure out, okay, this customer is probably a fraud or non-fraud customer, could probably become a fraudulent customer. So at least they will identify that this customer could be a risky customer, so to speak. So, and then eventually you check the performance. So one of the most important use case here is determining influencing factors. Now, why this is important? Now there are multiple variables, right? In this case, you have close to, let's say, 25 variables or attributes. But are all the 25 attributes important? To be honest, no. They might not be important, or they might be important based on business case study. So here, what you can do is you can see which variables are more important, and how do you do that? One thing is you have weight by correlation. Now correlation is simple, in which you see, okay, how much your variable or attribute is linked to your target variable. Let's say, just give an example, right? Let's say income of the customer. So if the income is increasing and he's doing a fraud, so higher income people are doing more frauds, then probably, okay, this is correlation, there is a bit of correlation. And okay, let's say maybe a region, right? If this specific region is more fraud, then more customers coming to this region have more fraud. So this is just pure play correlation. But is this the only way you can do it? No. But can you do it only with this? Probably yes. So my case, I have preferred to choose 4 different methods to determine influence factors. One is correlation, one is Gini index, one is the information gain. These three are from decision tree. So you would actually be able to figure out, based on these decision tree algorithms, which actually are the important factors. But I've just not taken this individually. I have created an average, generated new attributes, and create an aggregate for this 4 different variables. So this actually helps us to figure out which variables are more important, and eventually we can apply the model and get our results. So right now we can look at the results. So as I already mentioned, right, so you have your predictions coming from the model. Now this you already had. These 3 are the newly added attributes. So one is the prediction, whether it's a fraud or not, confidence of that case to be fraud, fraud, and then that's non-fraud. So basically, these predictions, tell us that okay, whether in the customer is fraud. So think of it like this. So in this case, you already have the fraud levels, right? But in real case, you might not. Mostly, you won't have this level because this is your unseen data. But here we have for the entire data, and we have distributed that data into 80-20 principle, and we are applying our model on the 20% data. But still we have the level, but this is not going to happen. But since we have the level, we can measure the performance of the model, how good our model is, because here you can see, as I already mentioned, that it's really a false, that is not a fraud, but it's identified as fraud. But then there might be things like, okay, how good my model actually is, right? This is a very important question, because you're doing all the predictions, and then if your model is not giving correct results, you are marking customers who might not be fraud as risky customers, and you have to spend more time and money to get the more details about that customers. Maybe you do a field survey. So this might be more cost. It's not a cost effective, right? So if it is a fraudulent customer, if it is non-fraudulent customer, also it is not a cost effective technique, because you're spending time and energy and money to find out the customer is a fraud or not. So the algorithm, how good the algorithm is, that's really important. It also gives you the algorithm also gives you a confidence score. So let's try to find out how good an algorithm is based on the performance, right? So just by going with the accuracy, it's almost 75%. So that means out of every four cases, three cases has been correctly predicted. So let's say the four frauds, three had been correctly predicted. But let's look at the precision and recall for this. Let's say fraud customers. So true means it's really fraud customers. Predicted true means it's also predicted to be a fraud customer, right? Predicted false here in this case, this one shows you it's actually fraud, but predicted false means it couldn't correctly predict. So that's where precision is recall and precision are important for the fraudulent customers as well. So for the fraudulent customer, you see it is wrongly predicted 53 customers at fraudulent customers, which are not non-fraud, but 132 it has been correctly predicted. So out of 132 plus 53, that is 185 customers, 132 has been correctly predicted as fraudulent customer. So the class recall comes out to be around 72%. Similarly, of all the fraudulent customers predicted as fraud, 132 has been correctly predicted. So the class precision is also around 72%. So which is okay. You can make it better. As I said, I have only used two algorithms here. You can use more algorithms to figure out which is giving you the best results. So and also you can do more analysis, of course, to get better results. You can eventually make it better to get better performances. So the next thing is also let us look at the different attributes, the important attributes, right? So here you see your fault, policy type, in fact vehicle category. These are the really important. So close to one is more prone to frauds. So policy number, past number of claims, these are important. So all I'm saying is this, these are important, and this might not be marital status or age of vehicle might not be that important based on this analysis. But of course, if the insurance company thinks that this is usually really important, they can still use this. Now in terms of also the performance, right? So you don't have to just rely on the machine learning algorithm. You usually the insurance customers have their own business rule engine to figure out which customers can turn out to be fraudulent customers. So the combination of the business rule engine or the domain knowledge which they possess, and combination with this machine learning analysis or machine learning algorithms used in this RapidMiner, they can really get the best results. Because again, as I said, this is the drag and drop operators. You don't have to write the code. So domain experts can pretty much do this analysis by themselves as well. So yeah, so now these are the important attributes. So let's say you think, okay, maybe you can do multiple iterations and find for yourself, but maybe first 20 attributes can give you much better results, and they could be enough to just build this analysis. So why I'm saying this, so if you use more variables, there's a chance of overfitting, or it will take much more time as well because you're running on more number of variables. So it's better to use let's say the limited number of variables which you think is right for your use case. So that's where domain expertise also comes, where they know which attributes could be really more important in this use case. So and finally, also you can look at the ROC. So this is the area under the curve. So basically, more the area under the curve is, the better is that algorithm. So here, this is like almost not doing a great result. This is the KNN. We have used two only. A decision tree is giving better results. But if you use more algorithms, there's a good chance that you will have better results than this. So that will also help you to figure out, a much better that which customers are actually fraudulent customers. So right now, I have only built this workflow kind of a case study where you can actually drag and drop the operators and build the model. This is a very simplistic version. You can do much more complex analysis than this, but this is just to show you what you can do, just dragging and drop, dragging and dropping the operators and building the model. But as I already mentioned, you also have turbo prep for cleaning the data, and you also have auto model. Now let us look at the auto model. So I have already taken the data. And also loaded it. But basically, what it does is you have different algorithms here. Like you have naive Bayes, generalized linear algorithms, logistic regression. So all these different algorithms tells us your classification error rate. Here you see the errors are around 6%, right? Which is pretty much okay. It's not too bad. It's good enough. So there are almost 6-7 algorithms which has been used here. Also, you have the runtime. So you can choose the algorithms which model you want to deploy. So you want to, let's say, deploy less time, and you can take a combination of both runtime and classification error to choose the algorithm of best suitable for you. But here you can see the runtime for different algorithms. So let's probably take random forest, which is probably one of the widely used algorithms in the industry, where you can, this is now you can individually visualize the tree as well. So that is one thing. But I think also the interesting part is here, random forest also give its weights. It's also tells us how important which variable is by its own, right? This is auto model, remember. That is not the same thing which you have already discussed. That is we had to build that model using the drop and drag workflow here, right? But here this is auto model, right? It will do everything on its own. So here you are saying that which categories, which variables are more important. Here it's saying, let's say for example, vehicle category is very important variable, a policy type, is a policy holder. So these are the very important variables it figured out, right? Now most important part in this whole thing is the simulator. Now actually you can just use the simulator and figure out based on your use case, which variables are the influencing factors, and if we change it, and what happens, like mostly is the variables, if that customer is going to fraud or not. So I mean, these are just examples here. You can so it's for a particular case, use case where you have the different attributes, so you can optimize, right? So here the range one is the non-fraud customers, so you can actually change to, let's say, range 2 for the fraudulent customers. And you can choose for standard deviations also, with how many standard deviation you want to take. And finally, based on this, you can run your optimization, and then you can see, you can also drag and drop this, right? To check, okay, which variables are responsible, and if you want to change it, then do you think that chances of that customer turning out to be fraud is less likely or highly likely based on this, just changing this, you can just change this indicator here. So that is what the simulator can do for you. Also, the another important thing is performance. You can check how good the model has been performed. You can see the accuracy, the errors, precision, recall. So this is pretty good here compared to my previous model, which I've shown here is 94% and recall is 100%. So this model is actually better than what I have built. So maybe you can use this model just for example. And then this is the lift chart also you have, right? So that specifically says, now the lift chart is very important. The lift chart says, how much of the variable, how much of the fraudsters it is able to catch in initial, let's say 10% or 20% of the data or more. So that is also a good indicator of how good the model is. So finally, you can also come to the predictions, right? Now here you can see the different attributes which actually helps you to figure out what. So the red has, the red shows, okay, this probably turned out to be fraud. So that's something which you can just looking at this, you can figure out which customers could be doing fraud. So finally, you can also build the production model here. So what I'm trying to show you is here, there are different options you can have. This is auto model where you can you can go ahead and also you open the process, which I've just shown it to you. You can see the entire process and you can make your own changes as well. But you can have a look at how they have built the process as well. Just you can clicking on this process. So the similar to the one which you have created. At the end of the day, this is again a process which has been built automatically based on the data set. So you have different operators here, and you can also compare which one is better, and based on this, you can actually build your model. So the advantage here is, as I said, if you think about this, is you might not be a great coder, let's say, but this tool is really a code free and code friendly platform where you can actually go ahead and build a vehicle insurance fraud case. Because I think the major problem happens where domain experts, they cannot convey their message at times to the developer teams, and eventually there are projects which doesn't kick off where developer team doesn't know what the domain experts want. So eventually it takes time for them to also get things going. But in this case, they can, both developer team and the domain expert can work on the same process, and they can build the process. So that's one thing. And the second thing, also the domain expert can really build a proof of concept very fast, and eventually they know that, okay, this is what I am looking for, and that's, they can convince the business to maybe change certain decisions or make some important decisions. And also they can show this process to the developer team, and they can also build a model accordingly. So these have numerous advantages, but just to show you, this is just different techniques. This is, you can also use the workflow model, you can also use the auto model, but the main thing is your business problem could be solved just using this drag and drop operators or the auto model. But in short, RapidMiner could be greatly, I mean, it's a great tool for you to do your analysis. Thank you.